Okay. Okay, students. So now we will see some examples in embedded system development cycle. So this is the embedded system development cycle. Any embedded system wants to be in application. This is the steps they were following to develop. Okay. So first, you have to determine the requirement. I told you last class itself, when you take any embedded system, you have to take the requirement. For example, when you take the washing machine, in the washing machine, you have to determine the requirement. So what the washing machine has to done. For example, what are all the motors are required. Okay, DC motors, how many DC motors are required, how many stepper motors are required, and for example, now we have some display screen and all. So LCD screen, and similarly, we have to know the LED on and off indication, and then inlet valve and exit valve, that and all we have to determine the requirement. Then you have to design the system architecture. So for example, when you have to take the microcontroller. So which pin you have to connect. For example, there are ports where they are in microcontroller. So we have to select which pin and all, which we have to. For example, port 0 has to connect it to stepper motor. Port 1 has to connect to the rinse motor. Port 2 has to connect to the spin motor. So that's when we have to design the system architecture. That is, microcontroller has to connect with what are all the hardware requirements. Then select the OS, select the operating system. So when you see with 8051 is a microcontroller. So definitely the language or programming, we use only assembly language. But when you go microcontroller with the embedded application, we have an embedded C. But it is also mainly depends on the coding of assembly language only some slight modification. So you have to select the OS, operating system. Okay, so where we have to so embedded C, assembly language program, and then choose the processor and peripherals. I told you that processor and peripherals in sense same thing. We have designed the system architecture. We have decided whether it's a microprocessor needed or microcontroller needed, what and all needed we have to decide. Then choose the development platform. For example, I have written the coding. So while I'm writing the coding, I have to embed all my program in a chip. So we all know microcontroller have onboard memory. So for example, in our lab also we will do. We will write the program in 8051 and we will transfer all the programming into the 8051 chip. For that, we will use the Keil software. So for that, you have to identify which development platform is needed. Then code the application and optimize. Actually, you have an option to do this while they are designing the embedded. They won't directly do in the platform. Just what they will do, they have to do the simulation. So in the simulation, they will real time, or they will connect all the components. Actually, in the lab, we were doing in the Proteus software. The same way, you have to code the application and you have to verify. So that is the next step, verify the software on the host system. So we have to verify in our host system whether it is working properly. We have to put it in the target system. So this is the embedded system development cycle. So mainly we have to choose the processor. Depending upon the processor, we have to choose the peripheral, and choosing the peripheral, we have to write the programming. After writing the programming, we have to code it in the chip, and before verifying on the target system, we have to do the development in our host system. Once we verify in the simulation, then we have to verify in the target. So this is the embedded system development cycle. Why I am explaining this and all now, this is the introduction part. Even though you will study elaborately in the 4th unit. Okay, today our main target is to know 8051 pin diagram and 8051 architecture. So to know that how we were connecting and all, just we will see some few examples, then we directly move on to the architecture as well as pin diagram. Okay, and this whatever I said, all this will be given and determine the requirement, determine the system architecture, everything. Select the OS, choose the processor. I told you microprocessor, microcontroller, digital signal processor will be used. Okay, then choose the development platform. Then you have to assembly language or C language. You all know compiler, assembler will be there. What is the difference between compiler and assembler, ma? Compiler and assembler. Siva Subramanian, register number 23. Can you tell what is
Yes, ma'am.
yeah, tell me what is compiler, what is assembler?
Compiler.
What it will do? Or anyone can know? Compiler will convert the high level language into
Machine level language.
very good, machine level language. Assembler?
Yes, ma'am.
Assembler?
Assembler.
Assembly level
Assembly
language.
level language to mission level language.
Very good.
Machine.
Yeah. Give some example for a high level language. Very simple
C
question.
programming, C++.
Yeah, C, C++, Java, .NET, all will comes under that. And assembly language?
Like MATLAB, ma'am.
No, assembly language. We have studied 8085. 8085. That all assembly language. You have seen that the development starts from assembly to high level language. So 8085 ALP. We will do assembly language programming. Move, LDA, LXI. Have you studied na? That and all assembly language. So that assembly level language into machine. That is assembly.
Machine
So
level
you
language.
have to code the application and optimize the code, whether it is working properly or not. We can't able to go and do it in the target system. So we will do it in our system itself, and we have to verify the code whether it is working properly or not. Okay, so verify the software, whether I told you now, source code into object code, whether it may be a compiler or high level language you are doing or assembly level language you are doing. So that and all you have to decide it, and you have to then install the program on the chip. Okay, so this is the embedded cycle. In the embedded cycle, we are not only depending on the processor. We have to design analog components are also needed, digital components also needed, and we have to convert analog to digital, digital to analog and all. Then application program, exception handler are also required. So while I'm doing my program, definitely I have to check it in my host system. I need all these components, not only processor, the other assembly components also needed. Okay, I have you. I think day-to-day life we were using an ATM, and ATM is also using one of the best example for the embedded system application. So this is the layout I have given out. That is screen, button, receive. Each and every process they have one processor, they have one controller to monitor. So when card reader is there, that is definitely card reader means the security wise it will be very high. So definitely the card reader they have put a separate controller for that. So speaker will be there. So for each and everything they have. So everything will be embedded. Okay, this is one ATM. This is one digital camera example I gave for you people. I think you can understand how the processor is happening in digital camera. So digital camera, first what we will do, we will capture the image. That is converted into digital form. Okay, once it is converted into digital form, what happened? Olden days, it is not like that. Everything will be stored in a film. And what happened? It takes some process to convert. Now it's not like that. Once we we capture the image, automatically it will stored in a digital form, and we can easily transfer into our mobile or our laptops and all. So it will be stored in our internal memory. From the internal memory, we can transfer the data to our own system. Okay, so smart camera can able to capture the detail of the scene, when you have taken, where you have taken, date, timing, everything will become. So obviously there will be a clock will be there, so you can know at what time you have taken, what date you have taken. That also fetched in the images. Okay, so and then it not only it will capture the image, we all know we can take the videos also. So this is a program, this is a digital camera what we were employing in a day-to-day life, and you can see the embedded system of the digital camera. You see, this is my processor. Here I used to you have seen some co-processor is also there, but this is my main processor. So in the main processor you have seen that memory is there. To capture the image, to store it, I need a memory. Okay, and you have seen that the lens converters are also there. So you have seen there is a camera DSP is there. I can convert my analog value into digital value. I can save it there. Okay, and similarly here you see that Bluetooth module is there to transferring. So to capture the image, storing the image, I need a memory unit. And similarly, if I want to transfer the image to through Bluetooth or to the cable, I need some RS-232 cable, Bluetooth and all. and Ethernet facility is also there. So similarly, in the camera, I can see the images also. So definitely I have one LCD screen also in the back. So I have a LCD. So video embedded, because not only it will capture the image, it will capture the video also. So video out is also there. So the everything is on embedded. So the heart of the system is processor. Without processor or controller, we can't do with this. So here coprocessor is also there. Okay, so this is the entire system. This is for camera I have given. Then one more example we will see. I think we were very fashion about the cars and all, the olden days, and now there will be a development, and the automobile industry is very huge depending upon this controllers and all. So when I take automobile industry, while they are manufacturing, the engine will be even that will be in the thing, but nowadays the futures they were adding with this will be mainly depending on the embedded. So you have seen nearly some 100 microprocessor they have embedded in the automobile industry. So even this embedding this controller, microprocessor and all, the cost of the car will be also get reduced. So you see how they were using the car. So 4-bit microcontrollers will check the seat belt. You have seen in some of the car, you didn't properly put the seat belt, it will indicate there will be you have to check your seat belt. So even they have adopted one microcontroller for checking the seat belt. So not only a single controller will do all the things, they will use nearly some 100 microprocessor to control all this engine. So they used some 16 to 32-bit microcontroller for engines, and some dashboard devices, dashboard, audio, speedometer, everything, they will use the microcontroller. Okay, and you can see this, they used sensors. Okay, sensors is very much important, and from that it will be converted into a digital signal, and then it will be connected to the controller, then it will process. According to the process, the indication will be there. So you have seen this is the car which they are having nearly 40 sensors, and there are 25 types will be used. Okay, so this is the overall view, and you just see this is the inside and engineering view. Okay, I think you are in the final year. You have learned everything. Can you understand? Motors, you have learned AC motor, DC motor, everything. And when you take a electron devices subjects, you have learned about all devices. And even you have completed the microprocessor. So now you are learning about microcontroller and embedded system concepts. So this is only the application point of view you are learning. So whatever you are learning, I think you can see in measurement and instrumentation, you have learned about all panels and all. Okay, and engines, stroke engines and all will comes under the mechanical part. So when you see this, there will be students. 86 Subramanian, please put your mic in mute, ma.
Sorry, ma'am.
Yeah. So this is the entire as an engineering view. You can see that for you have seen there are only for each and every operation. Now the wiper is working automatically. The olden days the wiper all are mechanical, hydraulic system it is working. Now it is everything is become a digital. So for each and everything there will be a controller or there will be a processor. Depending upon that they will connect to that and automatically it work. But when you go with the processor, this we have to need the cost of the system will high. But depending upon the requirement, they will use processor or controller. But small applications, they mainly depends on controllers only. So when I am my wiper is working automatically, now definitely there will be a motor. So now you can see the wiper can splash some waters also. So depending upon the situation and all, so automatically it will clean. So definitely there will be some mechanism. So you can see this. This is the down you have seen CAN. So I told you one network is there now. Everything has to be connected now. That is controller area network. So through that each and every processor, everything will be automatically connected. And now we have a GSM. GSM that is global system for mobile communication. So we can know that. So GSM if I install automatically I can know. GPS is global positioning system, and I can know my place. Even it will be work in the mobile, laptops, all the systems the same GPS. So the thing is they will go with some common area network. There they will embed the microcontroller and there they will connect. I think you have seen some universal motor. And you have seen all the thing, each and every purpose. See it, they will indicate. I told you they connected one microcontroller. Okay, GPS to know the specific location. Okay, window lift also. You can see now the automatically when you press the button, the window lift will be there. So each and everything wherever the motor is required. So you have seen the speed of the motor. Okay, if the wiper has to be moved fast now, my speed will be around some 100 rpm. But if I want to lift my window, that is required some 10 to 20 rpm. Depending upon that, they will choose the motor. And you all know everything is battery dependent. All the power will be get from the battery. And for microcontroller, we need only 5 volt. Okay, so the 5 volt is required to operate my controller. So through that entire system will be controlled. Okay, and again the same thing, embedded system. When I'm going for steering, brake and all, so CAN bus, they use the common bus, controller area network, they use this bus. And you have seen this is a anti-lock braking system, ABS module. So you have seen this is the lab ABS model they have given, very simple model. So automatically during emergency condition, this anti-lock braking system still works. So mainly thing is they will connect with the disc brakes will be there. So you have seen this will be connected with the wheel, and this brake will be work automatically whenever under the emergency or harsh braking condition it will work. So the module will be very less, and it will be also operated through the hydraulics. So you have to understand our embedded system, the heart of the system will be the microcontroller. So students, this is some applications, live applications we were using in day-to-day life we have seen. Now we are going to directly enter into the microcontroller. We will see what is the type of microcontroller, and we will see the pin diagram, and we will see the architecture. This is our today's agenda. Okay, now type of microcontroller. So type of microcontroller depending upon bits, 8 bits, 16 bits, 32 bits microcontroller will be there. Okay, and then I told you now we are going to learn 8-bit microcontroller. Okay, then memory, embedded external memory. We have a both on-chip memory, external memory is also there. Okay, instruction set, RISC, CISC. Okay, I already told you RISC means what? Yesterday, reduced instruction set computer, complex instruction set computer. So that is RISC and CISC based. But when you do 8051, that is CISC based system only. So we will go with one more microcontroller that was only reduced. Nearly 40 instructions only there. So using entire 40 instruction, we can control the microcontroller. So it is easy for us to do the programming. Okay. So then memory architecture. Harvard, Princeton. Princeton is nothing but, I told you yesterday, von Neumann architecture. Na? So the same thing. Harvard means what? Program and data, I have a separate memory. Von Neumann means I have a, Harvard means program and data memory, I have separate memory. And von Neumann architecture means that will be combined in a single memory. So program is also in a single memory, data is also. So I have to identify which is data, which is program. But that is not problem in the Harvard. Program separate memory, data separate memory. Okay. And IC chip, VLSI, I told you 8051 is also a VLSI code. Okay, and then this is the family. Family means the microcontroller is not manufactured by a single company. It is also be manufactured. See, Motorola, PIC, Hitachi, Texas, ARM processor, Siemens, Atmel, Philips. There are so many companies are there. But now we are going to learn 8051. 8051 is microcontroller, 8-bit microcontroller. It is a Harvard memory architecture, and this is a CISC based microcontroller. Can you understand? And this is the thing, this is we have seen overall types of microcontroller. Okay, now we will directly enter into the 8051 pin diagram, because where I have to connect what are the pins, that is. So remember, while remembering pin diagram, you need not to remember the pin numbers and all. That is not required. You have to know what are the pins available in 8051. See students, this architecture, this pin diagram registers, it's not a, it is manufactured mainly by Intel. So whatever I am setting that, so I'm telling about this microcontroller. This all about Intel manufacturer. So they itself designed the microcontroller. They itself designed the architecture. So it's a standard architecture. You have seen this Intel is now a very popular processor. So we were learning the basic thing, and you know how to connect. Even when you go with the higher standard, even Arduino or Raspberry Pi, you can understand the very well concept. That's why we are learning from the basic, and when you move on to the higher end processor, you can understand how the work is there. So now we are going to learn about this microcontroller. See, you see, this is 40 pins. Okay, so I told you this 8051 microcontroller is 8-bit only. So how many bit data bus? 8-bit data bus. Okay, by 8-bit data bus, but the address bus will be how many bit ma? 16-bit address bus will be there. Okay, so you have seen D0 to D7. D0 to D7 will be the 8-bit data, and 16-bit address bus. I told you 16-bit na A0 to A50. Okay, now you see totally 40 pins. Very easy to remember. 4 ports are there. In microprocessor, you have studied 8255. Programmable peripheral interface. Through that only I can connect with my external peripheral. But here I can directly connect with my ports. So how many ports are there, ma? 4 ports. Each port 8 bits. So 4 into 8. How many pins are there allocated, ma? 32 pins. So out of 40, 32 pins they allocated for ports. Okay. Now we all know microcontroller means we need a supply ground. Okay. So 2 pins they allocated for supply. One is for +5 volt and another for ground. Okay. So 2 pins they are allocating for supply and ground. Then you all know the processor will works on the frequency though. So the oscillator will be because time consumption, and when we see it takes a time, speed, everything is depends on clocks. So the clock must be very important. So here we have 2 pin we are allocated for oscillator. I think this oscillator you will study about LC oscillator. You studied in electronic circuit. So here whatever you have studied, the application only we were studying in the embedded system. Okay. Then reset. Reset means if I want to reset the microprocessor, if I press, if it is logic 1, automatically microprocessor will reset, and it will reset the peripheral devices also. So the 1 pin they are allocated for reset. So 32 pins for ports, 2 pins for supply, and 2 pins for oscillator circuits, and 1 pin for reset. So we have seen 34, 36, 37 pins they allocated. So it's a common one. Okay, the ports only new for you. So the remaining 3 pins, okay, this is the 3 pins you have to learn. I think when you studied about microprocessor, the pin diagram itself, it is very complicated. So many things you have learned. But you are seeing here very simple thing. You can understand what is the thing and what they were connecting. Okay, ALE. Anyone tell what is ALE, ma? It is one of the important. See what
Address
we learn.
latch enable.
Very
Address latch enable.
Superb, ma. Address latch enable. Actually, what is the purpose of address latch enable? Now, we will multiplex address and data bus in a single line. Okay. Then, whenever data will do, the ALE pin will demultiplex the address separately and data separately. So, to avoid the number of lines in the microcontroller, we always multiplex address and data bus. So, to separate the address and data bus, ALE is used. Okay. Then PSEN and VPP. This is mainly to access the memory. That is, we will see while we are discussing about that. Okay, so to access the external memory, we will use the PSEN pin, and to access the internal memory, we will use the EA pin. So this is the main thing. I think you have understand. Totally 40 pins, 32 pins for ports. 4 ports are there. Port 0, port 1, port 2, port 3. Each ports 8 pins. So totally 32 pins. Supply 2 pins, 4. Okay, so oscillator 2 pins, reset 1 pin. Apart from that, these 3 pins they are allocated. Okay, now we will see in detail. Okay, now we have seen this pin detail. I think it is very easy for you to understand. Port 1 to 8, you have seen port 1 to 8 means what? How they allocated? Port 1.0, port 1.1, port 1.2, port 1.3. 1.4, 1.5, 1.6, 1.7. That means why we used 1.0 now? In this microcontroller, we have a bit handling instruction. I have already told that is very popular in microcontroller. We have so many bit handling. So if I give set B port 1.0, automatically my bit will be set. CLR P 1.0 means my port will be clear. So I can switch on one port and I can switch off one port using bit handling instruction. So they have given the port in this way. Can you understand? So these ports we don't have any other functions. So that means you have understand that we have a internal pulled up. What is pulled up? That means pulled up, pull down. Pulled up means we have a logic one. Pull down means obviously it's a logic level 0. So you have understand this are a pulled up. It have a logic level 1 external bidirectional IO ports. So bidirectional IO ports means what? Bidirectional input output ports. This ports one serves only this function. It will not do other function. But when you take the other ports bracket, they have one function. So it will serve as a port function, along with it serve as a other function. So we have a dual functions in the particular pin. But this port 10, we don't have any other functions. Okay. Then pin 9. Pin 9 is for reset. I told you it will reset the microcontroller and external peripheral device. Then you come to port 10 to port 17. Port 10 to port 17, which port they have connected? Port 3. I think you can see this port 3. Have you seen? Port 3.0, port 3.1, port 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, and so how many bits they are allocated? 8 bits. So you can see this port will serve as a port function. Apart from that, it have a bracket, we have a function. So it will serve 2 functions. So one pin can serve 2 functions. So here P3.0. So you can ask one question. How it will serve 2 functions? That everything will be written in the register. Whether you have to serve this function or that function, that the Intel manufacturer clearly specify at what mode it will work, then the receiving mode, interrupt, timer, everything they have written. Okay. So here when port 10 and 11, receiving and transmission. Okay, so this is for serial communication. Receiving transmission is for only serial communication. Then INTO, INTO on board. This is INT. INT means what? What is INT, ma? What is INT?
Interrupts.
Yeah, very good. Interrupts. So we have studied what is interrupt, ma? When I'm taking the classes, suddenly I have stopped and I have inquiring and you people are replying to me. That is interrupt. So the same concept, microcontroller is serving one purpose. And if any requirement comes from outside, microcontroller stops that and it will immediately attend. I think you have studied one of the important interrupt in 8085, trap, emergency. When you see they will connected one microcontroller with all other system. If there is any emergency or fire, any emergency condition occur, it won't check any other condition. The traps once sends a signal, microcontroller will shut off the process. That means emergency condition is arise. It doesn't have to do any other process. It has to stop the process and it give the attention to the trap. So that is external, not like that. This is an interrupt, external interrupt, INTO, INTO1. Then timer. I told you yesterday, timer and counter. What is timer? Na? Timer will generate the time delay. Okay, it will use to create the time delay. For example, time delay, the best example when you take the traffic light, red, light, yellow, red, yellow, orange, the light is switching from one condition to another condition. That is time delay. Okay. When you see the counter means when you see my 60, 59, 58, it is counting the time. So that is counter. Counter operation means the best example you can take the traffic light. Once it counts the happening, that is counter operation. Once it creating the time delay, that is the timer operation. So it will serve both the purpose, timer or counter operation. Okay. Then RD. RD means what? It's a universal command. RDW.
Read and write.
Very good, man. Read and write. So read the signal and write signal. So if I want to read any command or if I want to write any command, I will use the read and write control signal. Okay. The next one is 18 and 19. I told you this is mainly for what, ma? For creating the clock signal. So the frequency is 12 megahertz. When you study 8085 and 8086, it is around 3 megahertz to 5 megahertz only. Now you are seeing the frequency get increased. Frequency get increased means what? Time, the frequency, when I'm increasing the frequency, time get decreased. So time get decreased means what? The control accessor is working very fast, t equal to 1 by f. So my frequency is getting increased means my time is getting reduced, and automatically my speed of the processor is also get increased. That is the correlation between frequency, time to speed. Okay, the next one obviously then pin 20, that is the ground pin, and pin 40 supply pin. I told you the supply will be 5 volt or supply only I record. Now you come to this pin 21 to 28. So 21 to 28, which port they are using now? Port 2. So port 2 means, I told you how many address buses there? 15. That is, we have to know how many address lines are there and how many data lines are there. 8 data lines and 16 address lines are there. So you have seen the higher order A8 to A15. So it serves two purposes. A8, so a higher order address bus is connected to the port 2. When you see port 0, you have seen AD0. AD0 means what? What is meant by AD0, ma? AD0, AD1, AD2, AD3. What is
Address
AD0,
data,
huh?
address data line.
Very good. Address and data lines are multiplexed. Can you understand or not? So that's why A stands for address and D stands for data. So both are multiplexed in a, so this is my address bus. Okay, A0 to A7 it will serve, as well as D0 to D7. That's why I simply mention AD0 to AD7. When I'm coming for higher order bus, it will serve one, it contains only the address lines A8 to A15. Okay, now P send, you indicate P send bar. Bar means what? It will work only under the logic 0. So if I want to access the external memory, I go with P send. Program strobe enable. Okay, so I told you microcontroller have onboard memory as well as external memory. So similarly here, P send bar is mainly used to connect the external memory. Okay, so if it's logic 0, it will connect with the external memory. Then pin 30, I told you address latch enable. My address and data line will be multiplexed. Multiplex means send in the same line. Demultiplexed, both address and data will be separated. So whenever ALE signal goes high, it will separate the address and data. I think you have drawn in the timer while you are drawing the diagrams of in 8085, you will indicate ALE to separate the address and data. Same purpose only save. So PORG, actually ALE serve two purpose. High means ALE will serve. PORG, the bar means what? Logic level is 0. So for my programming pulse, when I want to programming EEPROM ROM, we all know read-only memory. I have an option. So if I want to embed that program, I have to use the PORG button. Pin. Okay. Then pin 31. I told you external memory, which pin we use? P send bar. Internal memory, if I want to access my internal memory, I have pin 31. That is external access input. If I want to enable or disable, for example, if my EA pin is, yes, anyway, some of them were not. Yes, ma. Yeah, please put your mic in mute, ma.
BBA ma'am. நான்
Yes.
BBA join பண்ணிருக்கேன் ma'am.
Number
இன்னைக்கு class
10.
இல்லன்னு.
Register number 10.
Yes ma'am.
Yeah. Please
Shift
put
2,
your
ma'am.
mic on. Yes?
Yes, ma'am.
Okay ma'am.
Yeah,
Thank
please
you,
put your mic in the thing. Okay. Okay. So if my EA pin is connected to VCC, I can access my onboard memory. If my EA pin is connected to 0 or ground pin, I can access my external memory. So that's why they have given enable or disable the external memory. Whether I can use this purpose. Okay. Then pin 32 to 39 again. Port 0 is there. So I can use my address bus as well as data bus. So this is the totally 30 to 40 pins of microcontroller. So I will tell you in the thing, microcontroller, how many data lines, ma? How many data lines in microcontroller? 8 data lines.
8,
how many? 8. Address lines?
16.
Very good. Address lines, how many ports are there?
4, ma'am.
4 ports. What are they?
Port
Port
1, port 0, port 1, port 3, port 2.
yeah, port 0, port 1, port 2 and port 3. So you have to understand this is my pin detail of 8051. Now you understand, you just come to this. This is very, very important question, ma. You have seen this is not a problematic paper. It's a completely theoretical paper. So getting the marks, you people having some score in your CGPA, if you want to improve, you have to be concentrate on this. So this subject is a very scoring subject. You can have to understand what are all the important topics. So you have seen this. This is my architecture or functional block diagram. One of the important question in the first unit. Draw the architecture of 8051 or explain the functional diagram of 8051. This is the question of that. Okay. Now, whatever we have studied in the pin diagram, that we are going to correlate here and we are going to draw the architecture. Okay. So in my architecture, definitely I have to draw the 4 ports. You have seen here port 0, port 2 drivers, port 1 and port 3 drivers. You may ask why we have drawn port 0 and port 2 in one side, port 1, port 2 and port 1 and port 3. You have seen the pin detail is like that. So the same way they have connected like this. So port 0, so you see port 0 and port 2 on one side, port 1 and port 3 on other side. So you have seen here the same thing here you have to draw. So we all know port 0 is connected from both address lines and data lines, and port 2 have connected to address lines alone. Okay, now port 1 and port 1 3. So this is latch as well as drivers. So they have connected here. Then you come to the next part, memory unit. I told you we have a on-chip memory as well as external memory is there. So here we are talking only on-chip memory, onboard memory. So we have onboard RAM memory, onboard ROM memory is there. RAM means what? Random access memory. Okay, we have a both read and write operations are there, and ROM memory is there. So this RAM memory capacity will be around 256 bytes and ROM memory will be 4 KB will be there. So we have an onboard memory. This memory unit will not be in microcontroller. While we are drawing in microprocessor, we don't have this memory unit. But here you are supposed to draw this memory unit. Are you clear? After drawing this is oscillator. We already studied in the pin diagram. So I have connected my oscillator. Where I have to connect my oscillator, I have to connect my timing and control circuit. So through timing and control only, my entire operation has to be processed. So I have to interface my oscillator circuit with timing and control. You have seen my timing and control where it is connected. PSEN, ALE, EA, RST. Okay, PSEN means what? Program strobe enable. We have seen to external memory. ALE means what? Address latch enable. Then I have told you EA pin, whether I want to connect my onboard or external memory. We will see how we were defining on that. Reset. So this pins are we have connected to that. So you have seen one is through in, another are out. So depending upon how whether it is will receive from microprocessor or it will receive from externally. That wise, external means it will be in and it is out from microprocessor. Now the pin should be outwards. So this entire is timing and control unit. This is over. Now you come to the heart of the system. Heart is nothing but ALU part. Okay, arithmetic and logical unit. See, this is my ALU. In ALU, for all processor and controller, which is the primary register? Now, accumulator. Accumulator is the primary register. For all processor you take. So here also accumulator. What is the length of accumulator, ma? Tell me what is the length of accumulator? Anyone? Sandhya?
8-bit.
Very good. Because your data bus is 8-bit means your accumulator's length also 8-bit. There is no deviation on that. So this accumulator is also 8-bit. And here we have one B register. B register is a general purpose register. Okay. Then TMP2, TMP1. That is means temporary register. If I am doing any arithmetical and logical operation, my accumulator cannot hold the data. It will be temporarily stored there, but programmer cannot able to view the register. It is internally present in the microcontroller. Then PSW. Anyone can tell the full form for PSW? This all we have studied only. We know the words which is we are seeing only, not new to the microcontroller. We all studied. What is PSW, ma? It's
Program status.
very good, man. Who is 701? Excellent answers from you. Program status word. Shanmuga. Very good. Program status word. So
Ma'am.
program status word means depending upon the accumulator, the program status word will reflect the value. It is nothing but flag register. We have studied now carry flag, auxiliary flag. So similarly, this Intel microcontroller also have a flag registers will be there. So that will be reflected in a PSW. Then this port, this is one of the important port, interrupt, serial port and timer block. We have studied microcontroller. Interrupt, we have 2 pin, INTO bar, INTO1. Serial buff, we have used RXT, receiver and transmitter. Timer, we have a 2 pins. So all this will be connected to interrupt serial port. So you have seen this is connected to port 1 and port 3. Have you seen this? This connections will be there. Okay, have you seen here? All this will be my connected with the port 3. So if I want to communicate through this, I have to connect with port 3, and similarly port 1 I don't have any other functions. So through my TMOD timer registers, serial buffer registers will be there. So that I want to connect, I have to connect with my port 1 register. So please kindly correlate your pin diagram with architecture. It is easy for you to remember both. Okay. Now stack pointer. You have seen what is stack pointer, ma? Stack pointer is nothing but you want to access from memory. We have a stack pointer. We have a 2 popular instructions in microprocessor, push and pop. Did you remember push and pop? What push will do? Push will push the register into the memory. Pop will, what it will do? Yeah, Shanmuga.
Ma'am.
Push means push the content to memory. Pop
Will
will
delete, ma'am.
retrieve. Retrieve the content from the memory. So for that we use this stack pointer. Stack pointer will works under the principle of LIFO. LIFO means what? Last in, first out. Yeah, very good. Last in, first out principle. And then these are the other registers. You have seen program counter. What the program counter will do? Program counter will always hold the next instruction of the program. So next address of the program. So for example, 1 byte instruction mean it will hold the first next address. 2 byte now after the 2 bytes it will hold the next address. 3 byte instructions now it will hold the next 3 byte. So program counter will always hold the next address of the instruction set. So you have seen PC incrementer. Program counter, PC incrementer, depending upon the byte instruction, it will increment. And buffer for storage. Then program address register. DPTR, this is the only new word in the microcontroller we are learning, data pointer. Okay, this is a 16-bit register. And the other thing, this is also one of the register, we will see in detail. The other things, so what do you understand the architecture? The architecture, we have a 2 ports, so totally 4 ports. Then memory unit, ROM memory, RAM memory. Then we have an oscillator unit. Oscillator should be synchronized with the timing and control unit, and timing and control unit is responsible with this pin, the external pin, for to access the memory, or we have to reset the microprocessor. We have this part, and then this is my ALU part. ALU part contains what more? Accumulator, B register, and program status word or flag register, which contains the ALU. And the another important part is what more? Interrupt serial port timer block, which is connected with the port 3, and stack pointer, which is always relevant to the memory. That's why we have drawn near the port 0 and port 2. You have seen this all will communicate with the port 0 and port 2. So we have a program counter, buffer, incrementer and all. So we have one more register, that is what? Data pointer register. You will ask one question, ma'am, only this much of register we have. What are the register I told you now? Accumulator, then what I said? B register, then what I said? Data pointer,
HL.
stack pointer, program counter. I told only 4 register. Accumulator, B register, stack pointer, program counter, DPTR. Sorry, 5 register I told. You may ask, only 5 registers are there. No, we have some more register which is present inside this timer and block. We have more serial buffer register, timer register, interrupt register, all inside this block. Similarly, memory unit also we have a register that is called as a bank register. That is also present inside. So this is not visible inside. This is for architecture, this is not needed. So we didn't draw this and all. Can you understand? So we have drawn only 5 register: accumulator, B register, stack pointer, program counter, data pointer. So the remaining interrupt register, serial register, timer register, I didn't mention. Similarly, in this memory unit, we have a bank register. That is also we specify, not specified, but we will see in this detail. So this is, I think you all understand this, the architecture of this microcontroller very well. And this is one of the important question. Okay. Now, see, this is what I told you. 8-bit CPU register. What they told ma? A and B. Okay. And program counter is 16-bit register. Why program counter is 16-bit ma? Why program counter is 16-bit? Program counter will always hold the address of the next in. Very good. Address. Address means how many bits we allocated for address?
16.
16 bit. So that's why we have a 16 bit. So data pointer is also 16 bit. Okay. Then program status word. Program status word is a flag register. Content of the accumulator, the program status word will reflect that flags in the program status word. So that is also 8-bit. And stack pointer. Okay. So here 8-bit stack pointer only we use because onboard memory we have. So in the onboard memory capacity is 256 bytes only. So we will see why it is 8-bit, why it is 16-bit. I told you internal ROM, internal RAM. These are the internal memory of my register. What is my internal ROM capacity? 4 KB. Okay. And internal RAM is 128 bytes. So you see, in some of the book they mention 128 bytes. Some of the book they mention 256 bytes. So what is 128? What is 256? 8051 at starting they put 128, but they have put one additionally one extended version 8051A. That is 256 bytes. How we were upgrading the mobile, we were saying now the same way. The same way while upgrading the microcontroller, they upgraded to 256 bytes. Okay. So internal RAM, I told you register banks will be there. So register bank, now 4 register banks is there. Each bank containing how many register? 8 register. So 4 into 8, how many registers are there ma? 32 registers will be in the register bank. So totally they allocated how many bytes? 128 bytes. So 32 for bank register and 80 for general purpose memory and 16 for addressed register. So 80 plus 16, 96. 96 plus 32, 128 bytes. So totally this 128 bytes they allocated for the registers as well as memory access. Okay. Then these are the thing. The port 0 to port 3 already I have explained. 32 pins they allocated for port 0 to port 3 and 2-bit timer and counter T0, T1. And these 2 points. You just see this 2 points. These are the serial registers and control register. We didn't specify this because we will see in detail. We will see what are all the registers. So our serial data receiver and transmitter, SBUF. Serial buffer register we were using. And for control register, T stands for what? Timer. S stands for what? Serial. I stands for what? Interrupt. Okay. So TCON, TMOD means these two are timer register. Timer control register. Timer mode register. SCON, PCON. SCON means what? Serial control register. Power control register. Okay. IP means interrupt priority register, interrupt enable register. So all this register which is present inside the timer and control block. Okay. Then we not only 2 interrupts, we have a external 2 external and 3 internal interrupts. So totally how many interrupts are there? 5 interrupts are there. Okay. Oscillator and clock. So please people remember while you are explaining this architecture, draw this architecture diagram, list out the futures. Okay, and this is 8051 system clock I have drawn. Okay, so what is the frequency I told you ma? 12 megahertz. So you have seen that oscillator which is used to generate that 12 megahertz frequency, and you have seen this is my pulse. You have seen one machine cycle. How many states they have taken? 6 states. So you see this ALE. This is my ALE which is used to demultiplex the address and data. Have you understand? Okay, and this is the registers in 8051. I think in tomorrow class we will discuss in detail. So what are the, till this you have to explain about the microcontroller. Okay, architecture. So today we learned the one important thing: accumulator, B register, program status word, data pointer, bank register, program counter register, stack pointer, special function register. What are the special function? I told you pcon, scon, tmod, okay, tcon, IP, IE, serial buffer registers, timer register, and one more register is interrupt register. All will comes under the special function register. So you have to one more thing, memory capacity. What is onboard memory capacity? 4 KB, and RAM capacity is 128 bytes or 256 bytes. Yes, clear? Students, you have any doubts? Please let me. Please, will you ask your doubts, ma? Yeah?
No, ma'am.
Shall I go? You have any doubts? You have any doubts in the architecture, ma? So yesterday we have completed. Yesterday we have completed one topic, that is comparison of microprocessor and microcontroller. Today we have seen one important part, that is microcontroller architecture. It's one of the important question, and definitely this question will be asked in assessment. That much of it, not only in assessment, university also they will ask. So you have to remember the architecture, and then you have to list out these points while you are briefing about the architecture. Okay, now I will take the attendance. So kindly give your attendance, ma. Please, while you are giving your attendance, please unmute your mic and tell me, ma. Number 1, register number 1.
Yes, ma'am.
2,
Yes, ma'am.
3,
Yes, ma'am.
4.
Ma'am.
Ajit Kumar is absent.
Present, ma'am.
Yeah, okay. 5. Akash Singh. 6. Number 6 absent. 5 is absent. 6. 7.
Present, ma'am.
8.
Present, ma'am.
9.
Yes, ma'am.
10.
Present, ma'am.
11.
Present, ma'am.
12.
Present, ma'am.
13.
Yes, ma'am.
14.
Yes, ma'am.
15.
Ma'am.
16.
Present, ma'am.
17.
Present, ma'am.
18. 19.
Yes, ma'am.
20.
Yes, ma'am.
21.
Yes, ma'am.
22.
Yes, ma'am.
23.
Present, ma'am.
24. 24. That's 24 is special. Arun Rao. 25. Darshini.
Yes, ma'am.
26.
Yes, ma'am.
27.
Yes, ma'am.
28.
Yes, ma'am.
29.
Yes, ma'am.
30. 31.
Yes, ma'am.
32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35.
Present, ma'am.
36.
Jagan.
Jagan present. 36 Jagan absent. 37. 37 Jayashree. 38.
Present, ma'am.
39. Huh?
Yes, ma'am.
Jayashree is present. Okay, okay. 39.
That is
37
Yes, ma'am.
present. 39. 40.
Yes, ma'am.
41.
Yes, ma'am.
42.
Yes, ma'am.
43.
Yes, ma'am.
44.
Yes, ma'am.
45.
Present, ma'am.
46.
Present, ma'am.
47.
Present, ma'am.
48.
Present, ma'am.
49.
Present, ma'am.
50.
Yes, ma'am.
51.
Present, ma'am.
52. 52. Bosco, John Bosco. Where he went? John Bosco. Absent only. 53.
Present, ma'am.
54.
Present, ma'am.
55.
Present, ma'am.
56. Nandini. Nandini M. 56 and 57. 57 is present. 56 is absent. 58.
Present, ma'am.
59.
Present, ma'am.
60, sorry, 60. 59, Neetu Priya. Yeah,
Present, ma'am.
Yeah,
Present,
yeah,
ma'am.
written your
Present,
name
ma'am.
separately. Okay, 60,
Present, ma'am.
61,
Yes, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65,
Yes, ma'am.
66,
Present, ma'am.
66, Rahul,
Present, ma'am.
67,
Yes, ma'am.
68,
Yes, ma'am.
69, 69, 70,
Yes, ma'am.
71,
Present, ma'am.
72,
Present, ma'am.
73,
Present, ma'am.
74,
Present, ma'am.
76, 76, Afridi is absent.
Present, ma'am.
70, 76 present. 77,
Present, ma'am.
78, 78, Shashank. Yeah, 80,
Yes, ma'am.
81,
Present, ma'am.
82,
Present, ma'am.
83,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Present, ma'am.
88,
Present, ma'am.
89, 89, Santosh Reddy. He didn't came to the class. 90, Uma Mageshwari.
Present, ma'am.
91, Manmati.
Present, ma'am.
Yeah. 92,
Present, ma'am.
93, 93, Vijay.
Yes,
Yeah.
ma'am.
Yeah, 94,
Present,
Vinoba.
ma'am.
Yeah.
Present, ma'am.
701, Shanmuka.
Present, ma'am. Present, ma'am.
Ram Kumar.
Present, ma'am.
Maunika. Maunika, 703.
Ma'am, 24 present, ma'am.
Yeah, wait. Maunika is present.
Arun Rao.
Izad, 951. Izad Ahmad.
Ijaz present, ma'am. Present, ma'am.
Yeah. Vijay Kumar. He didn't.
Present, ma'am.
Present, Vijay Kumar. Very good. 24. Who is number 24, man?
Arun Rao.
Arun Rao, what do you say? Where you went, man, while taking attendance?
Ma'am, no signal, ma'am.
Okay. The absent is Akash in 5, 36 Jagan, 52 John Bosco.
Present, ma'am.
John Bosco is present. You people are late to the class, huh? Now only joined. 56 Nandini.
Sleeping, ma'am.
Will generate report automatically. Wait for one more day. Okay, students, I hope you have understand all. No. How you feel about this class? Actually, it's a
Yes,
break
ma'am.
time. Okay, I think I don't want to take you much time. So you kindly join in the same link after the break. So please try to join 5 minutes before, because while taking attendance,
ma'am.
it will, okay. Thank you, ma.
Okay,
Thank you.
ma'am.
Thank you for your
Thank you, ma'am.
cooperation.
Thank you.
Thank you.
Thank you.
Shishant.